This is question 40 from the GATE 2016 session 1 EC paper, where we are given this op-amp circuit and the voltages V1 to Vn and are asked to find out as n approaches infinity what the output voltage approaches. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. We can find out the output voltage Vout by superposition principle. Here I have taken the same circuit and drawn it with the odd voltages enabled and the even voltages nulled, and here is the circuit with the even voltages enabled and the odd voltages nulled. So let's analyze the circuit on the left. You can see that Vout is simply going to be the V plus node voltage into 1 plus Rf by R1. So we can see that there are n by 2 resistors here, and this is Rf. N by 2 resistors are in parallel, so R by n by 2 is the resistance here, and this is Rf. The value of R1 is 10 kilo ohm as given in the problem. The value of R2 is 1 kilo ohm. So all we need to know is what the value of V plus is. So you can get V plus using just a simple KCL, right? So the incoming currents will be V1 minus V plus by R2 plus V3 minus V plus by R2 and so on till Vn minus 1 minus V plus by R2. This is the equal to the outgoing current of V plus by R2, right? Since there is no current into the ideal op-amp. If you solve for V plus here, you will get that V plus is equal to V1 plus V3 till Vn minus 1 times 1 by 1 plus n by 2. Thus, this is the expression you will get for the Vout voltage in this part of the superposition. But you can see that this is simply 1 plus n by 2 times V1 plus V3, that is the sum of the odd voltages, by 1 over 1 plus n by 2, and both of them will cancel out, leaving you with just the sum of the odd voltages. Now for the even voltages, you will find that V plus is 0 volt. Why? Because the current into the op-amp is 0. So if there is any non-zero voltage V over here, that would cause currents to flow out through all these resistors, which must mean that the current is sourced through the op-amp. So the only way that no current flows out through all these resistors is that it's 0 volt here. So since now this is 0 volt, and because of that, it's clear to see that all the currents coming like that should be equal to the current going out like that. So minus V out by R is equal to V2 plus V4 so on till Vn times 1 by R, right? That is the sum of all these currents is equal to this current. So V out is equal to minus V2 plus V4, so on till Vn. So by superposition principle, I can now say that V out is equal to V1 plus V3 till Vn minus 1 minus V2 plus V4 till Vn. Substituting the values, we get 1 plus 1/3 till 1 over n minus 1 minus minus half minus 1 by 4 minus so on to minus 1 over n. This is simply 1 plus 1 by 2 plus 1 by 3 till 1 over n, which we know tends to infinity. So V out will tend to VCC, which is 15 volt. Thus the answer is 15.